And then from this equation, we need to decide which of the 4 conic sections we have. Okay, so I put all those standard forms up here. So let's first just focus on looking at the standard forms. So for parabola, we have y equals a, x minus h squared plus k, or x equals a, y minus k squared plus h. Okay, circles, x minus h squared plus y minus k squared is equal to r squared. Our ellipse, x minus h squared over a squared plus y minus k squared over b squared is equal to 1. We could also have that reverse, so the y minus k squared could come first. And then hyperbola, same thing as the ellipse except for with the minus sign. So x minus h squared over a squared minus y minus k squared over b squared equals 1, or the reverse. Y minus k squared over a squared minus x minus h squared over b squared equals 1. So when you look at the standard forms, one of these should be super easy to pick out because it is very different than the other 3. Which one of these conic sections does the standard form have of something that's just very different?
Circles.
No.
Circles is r squared.
Right, but that's just going to be a number. R squared is going to be a number, right? Parabolas. Why are parabolas different?
There's only one set of parentheses.
Yeah, there's only one set of parentheses and there's only one value that's squared. So for parabolas, either your x is squared or your y is squared, but they both won't be. Okay? So parabolas are usually very easy to pick out because you will either have your x squared or your y squared, but never both of them. Okay, so in circles, ellipses, and hyperbolas, we will always have an x squared and a y squared. So we need to figure out how we can tell the difference between these 3. So out of these 3, which one has something that's definitely different about it?
Not fractional. Circles.
Okay, circles aren't fractional, but ellipses and hyperbolas aren't until the very last step as well. So we need to think about it even a little bit further than that. How about the sign in between x squared and y squared? What's the sign between x squared and y squared for circles? Adding. Ellipses are adding, and hyperbolas, it's subtracting. Okay? So the subtraction sign between your x squared and your y squared is what clues you off that you have a hyperbola. You'll look for the fact that you're subtracting them. Ellipses and circles now are extremely alike. And I say they're alike because I could try to write the circle like an ellipse. So r squared is just a number, so I could divide everything by r squared. And I would have x minus h squared over r squared plus y minus k squared over r squared is equal to 1. And now that almost looks like an ellipse, right? But what's different about the denominators? These would have the same denominators where ellipse would have different denominators. So that's how you have to tell the difference between the circle and the ellipse. As you look for what number is attached to the x squared and the y squared. If it's the same number, you would have the same denominator, so you'd have a circle. If it's a different number, you're going to have different denominators, so you'd have an ellipse. So if we have x squared plus 4y squared minus 6x minus 7 is equal to 0, we first want to look at it and try to decide, is it a parabola, circle, ellipse, or hyperbola? So what are some things about this equation you know? Okay, so the x and y are both squared. So it is definitely not a parabola, right? What's something else that we can see about it? Okay, it doesn't equal 1 yet, you're right, but we'll get it to that form eventually. We are adding. Between the x squared and a y squared, we are adding, so that means we have either a circle or an ellipse. So then we have to look at the numbers in front. The number in front of the x is 1, the number in front of the y is a 4. So are they the same number? No, they're different. So since they're different, we're going to have an ellipse. Okay, so that's the first thing. You have to decide what type of shape you have. Once you've decided, now you can put it into standard form. So how would we get this in standard form? Yep, collect the x's, collect the y's, get them together. So here we have x squared minus 6x would go together, or plus 4y squared. Nothing else to add on with that because it's just by its lonesome. What should I do with the minus 7? Add it over. So it's equal to 7. And now we need to complete the square. So what would we have to add on to the x's? 9. So what should we add on to the other side? 9. Do I have to multiply it by anything? Nope. Okay, so what do we have? Good. X minus 3 squared plus 4y squared is equal to 16. Then how do I get this into standard form? Good. Divide by 16. So in our standard form would be x minus 3 squared over 16 plus y squared over 4 is equal to 1. Yep, and we do want to always name the point where we're at least going to start at. So here, we always start at the center for an ellipse. So where's the center at? Okay, so the center's at 3, 0. So we'll go to graph it. So we'll put our 3, 0, our center on there. Then how do we graph an ellipse? The box is the hyperbola. But hyperbolas and ellipses, we still start the same way by finding the 4 points. Yeah, so we look at the denominators, okay? Attached to the x, the denominator is 16, so that tells us how far do we go in the x direction? 4 each way, or a total distance of 8. Okay? And then in the y direction, y squared is over 4, so how far up and down do we go? We go up and down 2. Take those 4 points and draw the ellipse. Okay? That's it. That's all for this problem. Okay? So you're not going to have to tell me the length of the major, the length of the minor. You will not have to tell me where the foci points are. That's all you're going to be doing. Is that okay?
Yes, that's okay.
All right, let's go to the next one. Yep. How would we do it? We do 2a and 2b. So your major here, if you have 16, square root of 16 is 4 times 2 is 8. So this has a total distance of 8. And the minor has a total distance of 4.
So if you know that it's horizontal, then that means it's going longer, so you go to the bigger one?
Yep. Correct. 3y squared minus x squared minus 9 is equal to 0. Okay, so we have to take a look at this and we have to decide which conic section do we have here.
Hyperbola.
This is a hyperbola. Why would this one be a hyperbola? We are subtracting between our squares. So here we have 3y squared and x squared, and we are subtracting between them, so it has to be a hyperbola. So how can we get this hyperbola into standard form? Okay, so add the 9. Better write down the fact that we have a hyperbola first, though. So 3y squared minus x squared is equal to 9. Divide by 9. Why don't I have to complete the square for this one?
Because it's already in its thingamabob.
Yeah, there isn't x's or y's anywhere, so this would be it. So divide it by 9. So this then gives us y squared over 3 minus x squared over 9 is equal to 1.
That's your answer. Now you have to find the center.
Center?
0, 0.
0, 0. Yep. Nope. When we are subtracting has to be in between for these. For ellipses, the larger denominator should always be first. But for hyperbolas, it does not matter. Okay, so we want to graph this. So we're going to start at the center that we just found. And then we want to get our box. So we get our box the same exact way how we get our 4 points for the ellipse. Okay? You know it?
Yeah.
So how far in the y direction will I go?
1.5.
Yeah, somewhere square root of 3. So somewhere in between 1 and 2. So we'll go about there and about there. Many of you will find it convenient to just label those as the vertices so that you know which ones or which way you're going to open. Okay. How far left and right should we go then?
3.
3. We get that from the 9, so we'll go over 3. Now what should I do with those 4 points? Make my box.
Yes, sir. Now you have to do the X thing. Exit.
Yep. Yeah, square root of 3, we don't know exactly. You just put it about where you think it is. Square root of both, yep. So and how does the box help us? What does this give us? Yeah, the x, the asymptotes. So we'll draw in our asymptotes. Okay, so we have the asymptotes drawn in. And then how do we know which way this hyperbola goes? Well, we labeled on our graph where the 2 vertices are. Yeah. This is opening up and down. Well, we labeled that the vertices were there, but we just have to pay attention to the first variable. So if the y comes first, we'd be opening in the up and down in the y direction. If this were in reversed order, we'd open in the x. So start at the vertex and go towards the asymptote. You should always be getting closer and closer to the asymptote, never crossing it, never touching it, though. So there's our hyperbola. That one okay? All right, number 3, 2x squared plus 2y squared plus 16x minus 20y equals negative 32.
No, this might. It's both.
It's definitely not both a parabola and a circle.
It's a circle, it's the only we haven't done yet.
It's a mutant.
Circle, the only we haven't done yet.
Actually, we haven't done a parabola yet either.
Okay, so first off, okay, so we know it's not a parabola because there's both an x squared and a y squared.
And there's a plus.
So, and there's a plus in between, so it's not a hyperbola.
We already did an ellipse, so.
Well, but just because we already did an ellipse doesn't mean this has to be a circle, especially when it gets to assignments. So how do we know this one's a circle and not an ellipse? Yeah, the coefficients are the same. 2x squared and 2y squared, that's the same. So that's telling us that we're going to have, we're going to be stretched the same direction in the x and the y. So we'll just have a radius. It'll just be a circle. Now, when we do have circles like this, and your coefficient is the same, I'm going to suggest, because in our standard form, we don't have coefficients in front of our circles. So I'm going to suggest that we first just divide by whatever that coefficient is to make it a little bit simpler process.
Could you use the ellipse equation to solve a circle too, though?
You could use the ellipse equation to solve the circle, but then when you get to graph it, you would see that you don't actually have an ellipse. You'd have a circle, so you'd have to change your equation to the circle. Standard form for a circle is equal to r squared. It does not have denominators.
All right, let's do this thing.
Mm-hmm.
Are you going to give us like all of those for the test?
Yeah, this will be up on the board for the test. Yeah.
The charts and everything?
It'll be on my
No, you
iPad.
won't need the charts because we're not doing. You don't have to do any of the other stuff. You just have to do what we're doing right now
For the quiz?
for the test on Thursday.
Oh my,
All right, so we're going to start off since we have 2x squared and 2y squared. We'll divide both sides of the equation by 2 first. Okay? So if we do that, what's our new equation?
I don't know.
X squared plus y squared plus 8x minus 10y.
You're being.
Yep, so if we divide everything by 2, we have x squared plus y squared plus 8x minus 10y is equal to negative 16.
Now you combine the.
Yep, now we're going to collect our x's together and collect our y's together. So x squared plus 8x and y squared minus 10y is equal to negative 16. Now what would we do?
Now you find the missing link.
If we find the missing link, so we complete the square.
I think Miles is missing a few.
Okay, so what do we have to add on to complete the square to our x's? 16. So what should I do over to the other side?
Add 16.
How do you know when to like add them and subtract them?
Well, here we are working on opposite sides of the equation, so we would be adding. If you ever want to work on the same side of the equation, you have to make sure your signs are opposite.
Next one's 25.
So this we'd add 25.
Yep.
So
That means the radius is 5.
add 25. So what do we have?
We have x plus 8 or 4 am I on?
Yeah, so x plus 4 squared plus
Y plus
minus 5 squared is equal to
5.
25.
Because it's r squared. R is 5.
I agree with you that the radius is 5, but the standard form should say 25 over there.
I'm so confused.
So where's the center?
The center is negative 4 plus 5.
Negative 4, 5. And the radius is what?
5.
5. Okay. See, if I go to negative 4, 5, I see I'm going to be off the graph. So I'm just going to move my x and y axis around a little bit.
Wait, why are you doing that?
Because otherwise I'm going to be way off the graph.
It's going to be off the charts.
All right, so we'll start at the center at negative 4, 5. And then how far do I go?
5 is 5.
Yep, go 5 each way.
5 diagonally. Boom. Now you just.
That's my brain.
Boom. That is probably as big as my head. Nah.
All right, is that okay?
Yeah. Oh. Is that a big head?
Yeah, I just moved the x and y axis around so it would fit on. All right, let's look at one more example then.
Parabola.
Let's look at the equation first before you try to see what it is. X squared minus 2x minus 4y plus 10 is equal to 0.
I'm going on a limb here, same direction.
I think it's in
Because you only have one.
way to keep us hanging.
Okay, so a parabola, and what's the reason why?
Just do it, Lex.
Because only the y is squared here, not the x. Okay? So if only the y is squared, okay, so only the y is squared, so we have to get the x alone. So adding the 2x is a good first step. So we have a parabola. So we have 2x is then equal to y squared minus 4y. We know we're going to have to complete the square there, so we might as well just set it up to do that, and then plus 10.
Everything we do. Now you gotta complete.
Yeah, I got to complete the square. How can we complete this square? So add 4.
And then subtract.
All right. And then we have to subtract the 4 from the 10. Why are we having to subtract here instead of add?
I don't know.
It's on the same side.
Yeah, we're on the same side of the equation.
I don't like this one.
Yes.
Why is the 2 positive now?
We added the 2x to the other side of the equation.
Oh, and you just flipped it.
Yeah, I just flipped it. I did the symmetrical part of it so that it would be set up like our standard form. Okay, so then we have 2x is equal to, what will this be? Y what? Yeah, y minus 2 squared plus 6. Is this quite standard though?
No, that doesn't look right.
What?
You divide it all by
Okay, so it's divided all by 2 because it's a 2x.
That doesn't seem right. Are you sure?
So you get 1/2 times y.
Okay, so 2 is equal to, or x is equal to 1/2 times,
Where's that 1/2? 2 squared plus 3. That 1/2. Oh, God.
the 1/2.
Harry Potter did that.
We divided by 2, which is the same as multiplying by a half. In our standard form for parabola, we do not have anything in the denominator. We'd want to write it just as a number out in front. Okay, so where's our vertex?
Vertex.
3, 2. Now, we can just graph this by looking at the pattern, but in order to do that, we need to know which way it's opening so that we open it correctly.
Positive or negative up.
It's not opening up. It's opening to the right.
Why?
Because it equals x.
Because it's positive. Positive.
It's opening to the right because it is positive and it's x equals. Since it's x equals, we open it up in the x direction.
You see that?
So we start at the vertex, 3, 2.
Yeah, we got x.
Now, who remembers how the pattern works? Okay, so normally we do over 1 and then we do up 1 squared. So over 1, up 1. If we go over 2, how far up do we go? 4, because 2 squared is 4. If you go over 3, you go up 9. Now we're just going to take that pattern and think about it on its side. And we have a 1/2 out in front. So if we go over 1, instead of going up 1, we have to go up what? A half. So now we're going to the right, though, so we just have to think about going to the right and doing that. So over 1 and up a half. Okay. If we go over 2, we normally go up. What's 2 squared? 4. But we have to times it by a half. 2. So over 2, we go up 2. And we can graph it. Don't like the pattern? Yeah. Okay, it's just perfect squares, right? 1 squared is 1, 2 squared is 4, 3 squared is 9. This is a square in the formula, so this is telling us we have to square our value, how far away we are from the vertex, we have to square it, and then multiply it by the number out in front. So here, if we are 1 away from our vertex, we would be 1 squared, which is 1, but we have to make sure we times it by 2. So if we go 1 away from our vertex, 1 times a half is a half. 1 away from our vertex, 1 times a half is a half.
So if we go
2 away, 2 squared is 4,
times a half.
but we have to times it by a half. So we'd only move up 2. 2 away in the other direction,
Boom.
2.
So if it was like a 7 from it,
Then we'd be timesing it by 2.
Be 1.
So if it said 2y squared, instead of just going up 1, we'd have to go up 2, because we'd have to times the 1 by 2.
so you do 4 times 2, so you have
Yep, 8, correct.